This graph tracks world gross domestic product alongside global seaborne trade over the last few decades. The two lines move in near-perfect parallel. 90% of all global trade travels by water. Direct access to the ocean is a prerequisite for national wealth. But that absolute reliance on water isolates geographically unlucky nations. If a country sits entirely inland, like the nations trapped around the landlocked Caspian Sea, they are effectively cut off from the bulk of the global economy. In order to move their goods into the global production network, these states must invest heavily in massive overland infrastructure. Their entire economy depends on the political goodwill of coastal neighbors to grant them transit rights. In a connected global market, a missing coastline is a hard physical barrier to national power. Yet, having ocean access comes with its own geographical trap, the maritime bottleneck. Immense volumes of global energy and commercial goods are forced through narrow corridors like the Strait of Hormuz and the Strait of Malacca. Thousands of heavy cargo ships are jammed together in these shallow waters, turning natural straits into single points of failure. If a military standoff, a pirate attack, or a single logistical accident blocks one of these passages for even a few days, the global supply chain fractures. Shipping slows, energy prices spike, and the shock ripples globally. To escape this vulnerability, nations are exploring a radical solution. Instead of forcing ships through a vulnerable bottleneck, they are drawing up plans to bypass the choke points by carving new canals directly through solid land. By rewriting the physical map, nations take a fixed natural reality and turn it into a tool for strategic manipulation. Consider the Strait of Hormuz. Bypassing this specific choke point is a clear look at the extreme lengths a country will go to secure its trade. The engineering required for a megaproject of this scale is brutal. It means cutting through active fault lines, blasting millions of tons of solid rock, and executing earth-moving campaigns on a continental scale. Beyond the digging, navigating severe elevation changes requires complex hydraulic management. Engineers have to construct colossal concrete lock systems capable of safely lifting and lowering fully loaded cargo ships over mountain ranges. The financial risk matches the physical one. An engineered bypass of this magnitude carries an estimated price tag of $200 billion. Governments entertain that astronomical cost because reducing the risk of a shipping collapse has a higher strategic value than the money spent to dig the trench. Even when artificial bypasses are successfully built, they introduce new engineered limitations. Russia's Volga-Don Canal illustrates this. This diagram outlines the severe topographical hurdle of the Volga-Don Canal. Ships are lifted 88 meters through 13 staggered locks. This creates operational bottlenecks. A depth of just 3.2 meters restricts passage to small vessels, and freezing temperatures shut down the waterway for months. Then there is the political toll. Foreign vessels navigating this Russian waterway face discriminatory tariffs that are 5 times higher than their domestic ships pay. The host country holds total leverage over the route. To escape these compromises, nations like China are pushing to finance massive alternatives, like Thailand's proposed Kra Canal, specifically to bypass the Strait of Malacca and avoid relying on foreign-controlled bottlenecks. Carving a canal solves the problem of natural geography, but it immediately transfers that vulnerability to the political control of the canal's owner. The geopolitical theory driving this industry belongs to Alfred Thayer Mahan. He authored the doctrine of sea power, arguing that total control of the oceans equates to global supremacy. Under Mahan's principle, canals are not viewed as commercial shortcuts. They are critical military assets, built to project rapid naval dominance across hemispheres. The British deployed this strategy during the World Wars. They used their control of the Suez Canal to keep their own global supply lines and troop deployments moving, while denying access to enemy ships. Egypt later claimed the Suez and used it as a sovereign weapon. During regional conflicts, the Egyptian government physically blocked the waterway by intentionally sinking its own vessels right in the navigation channel. The infrastructure built to accelerate international trade can be flipped in a matter of hours to suffocate a rival's economy. In Saudi Arabia, the proposed Salwa Canal suggests a different use for the map. Unlike the Suez or the Panama, the Salwa Canal is not being designed to improve global logistics or to relieve a congested shipping bottleneck. This map visualizes the true geopolitical goal: Saudi Arabia intends to carve a waterway along the border to sever Qatar from the Arabian Peninsula. Plans include explicitly hostile additions, like placing a dedicated military base directly on the new waterway to monitor the border. The canal functions as an impassable moat. It economically isolates Qatar while visually projecting Saudi dominance directly onto the physical landscape of the region. Humanity builds mega-canals to escape the limits of natural geography. But we don't eliminate choke points, we simply transfer that leverage to whoever owns the new route.